So welcome to our next lecture. Myself, Dr. Mahesh Dembrani, working as associate professor in RC Position of Technology Sherpur from Electronics and Television Department. So today next topic, we'll see the vision of the institute. So vision of the institute to become a leading institute in technical education, fostering innovation, research, ethical values, and sustainable development for the betterment of society to impart high quality technology through innovative and interactive learning process and high quality globally recognized instructional programs, fostering a collaborative scientific temper among students with ethical responsibility towards the society, preparing students from diverse backgrounds to have aptitude for employment, entrepreneurship, and research with a spirit of professionalism. The vision of the department is to produce competent electronics and engineers with a commitment to serve society. The mission is to deliver innovative ICT-enabled and interactive learning, fostering excellence in electronics and telecommunication engineering, cultivate scientific inquiry, ethical responsibility, and collaboration to address societal and technological challenges effectively, empower diverse students with the skills for employment, entrepreneurship, and research, nurturing professionalism and lifelong learning. The prerequisite and course objectives are given over here. To main course objective today we are going to see to understand the theoretical foundations of linear nonlinear models and the principle behind probabilistic and advanced machine learning models. So in number 2 it is dealing with the different algorithms which are going to see classifying with the k nearest neighbors, decision trees, neo bias, logistic regression, least squares for classifications. So navigating classification algorithms, a machine learning guide, it provides the core classification models. So core classification models may consisting of the decision trees versus naive Bayes. So main important in case of decision trees and naive Bayes, the key strength is highly interpretable and subvisual. Whereas in case of naive Bayes, the fast works well with the text. The main weakness in case of decision tree is prone to high variance. It is consisting of the overfitting. Whereas its primary weakness is nothing but the assumes all features are independent. So trees handle complex interactions but overfit. Neobias is a faster but assumes features independence. Then we can go for the k nearest neighbor, which is nothing but predicts the classes based on the proximity, requires feature scaling to prevent noisy features and dominating. So key strength of the k nearest neighbor is nothing but simple, no training phase. The primary weakness includes nothing but the computational slow for large data sets. Then we can go for a generative or a discriminative that consists of the naive Bayes models, joint probabilities, logistic regression, direct reliance, posterior probabilities, which is nothing but a sigmoid softmax. In case of logistic regression, we can see nothing but the key strength, well-defined probability output, struggles with the non-linear patterns. So that is nothing but important with the validation and optimization. So k-fold cross validation, partition data into k-folds. So observation is used for both training and validation. So high bias, low variance underfits the training data. The bias variance trade-off, the low variance or low bias, nothing but gives the overfits training data. So k nearest neighbor, in case of k nearest neighbor, it is a supervised machine learning algorithm, generally used for classification, but can also be used for regression tasks. One-and-one algorithm which can be used for the both regression as well as classification purpose. It works by finding the k closest data points to a given input and makes a predictions based on the majority class for classifications or the average values for regressions. Since the KNN makes no assumptions about the underlying data distribution, it makes it non-parametric and instance-based learning method. K nearest neighbor KNN non-parametric instance-based learning algorithm stores all training instances, makes predictions based on the k nearest neighbor. No explicit training phase is nothing but lazy learning. Works for both classification and regression. Now how it is going to work? The algorithm works for both classification as well as for regression. Whereas in case of classification, we have to calculate distance from query point to all training points. Then find the k nearest neighbors, use majority vote among k neighbors. Then we can predict the most frequent class. That can be done by means of using the classifications. For regression, we can calculate distance from the query point to all training points, find k nearest neighbors, then average the target values of k neighbors as compared to classification where is the majority vote among the k neighbors. We have to calculate the average target values of k neighbors during the regression and then predict the average value. It was predicting the k most frequent class. It is going to predict the most frequent average value. This we can see and study all available on the website or Geek for Greeks also. So thank you for listening carefully. So I will end over there. Kindly subscribe our channel of our student radiology, electronic television department, Sherpur. Thank you for